Here's integrated 3. It's problem 1-19. It says, solve each of the following quadratic equations. If you need help, refer to the math notes box in this lesson. So when you're trying to solve a quadratic equation, what you want to try to do is see if it'll factor. And then you can use the zero product property on it. If it won't factor, then the next easiest thing to do would probably be to just get out the quadratic formula. Some of you guys noticed that you can solve anything with the quadratic formula, and perhaps you didn't learn how to factor. In this problem, it doesn't matter which way you do it, factoring or the quadratic formula. If you get the right answer, you get the right answer. But I always try to factor first, and I'll just show you the way I do it. I make what I call a diamond problem, and it says the word mad, multiply, add. So I'm looking for a number that multiplies to make 15, whatever this number is. And then actually what it is 1 times 15, which is 15. And then I want some, because that's a 1 right there. And then I'm trying to find something that adds to make whatever the coefficient of x is. So -8. So then I ask myself, how can I multiply to make 15? I know 5 times 3. And actually, if I make these both negative, then I've got it. Now, since this is only a 1 right here, I can just take this shortcut and just say, hey, it's x minus 5, x minus 3. And I can use the zero product property. The zero product property says if I have a factor times another factor, and the answer is 0, if something times something equals 0, then either this something equals 0, or this other something equals 0, or they both equal 0. So I solve them both using algebra. And I get my 2 answers. Could I have put those into the quadratic formula and solved it? Yes. Okay, this one, we did these in class. This one, I tried to factor it. In this case, it would be whatever 2 times -6 is. And then it has to add to make -5. And there's only 3 different combinations of numbers that would multiply to make 12, and none of them can add to make 5. So I'm just going to give up. I have to. And I'm going to get out my quadratic formula. Quadratic formula is -b plus or minus square root b squared minus 4ac all over 2a. And you use the coefficients of the x squared term, the x term, and the constant as a, b, and c. I'm sure this is a review to everybody. And then I plug them in. I skip a little bit of steps. The negative of -5 was 5, and then -5 squared is positive 25. There's my minus sign that came right out of the formula. There's my 4 that came right out of the formula. There's my 2. Right, because a was 2, and there's my -6. And then this is where I see most of the mistakes happening. I know that a negative times a negative is a positive, and I know that this minus sign is, I think of it as being kind of with that 4, so I've got like a -4, a positive 2, and a -6, so I know that's all going to make something positive. So I got my plus sign here. I mean, you can think of it a different way. You can think of it as 25 minus, and then you can think of 4 times 2 times -6 is negative 20, or negative 48. But a negative minus, or if you subtract a negative, it's positive. So either way that you think of it, just be very careful right here that you don't get your sign wrong. And then you have to just use the order of operations, so you have to add inside the radicand. And then I would just leave it like this. If you want to get some calculator numbers for that, some approximate numbers, you would go 5 plus root 73 over 4. So square root of 73 is about 8.5-ish. I wouldn't round it though, I would leave it in my calculator. And then divide by 4. So that's about 3.39-ish. And then I would have 5 minus root 73. Root 73, I remember a second ago, we found out that it was about 8 point something. Now I have to do it again. 8.54 or whatever. So I have to go 5 minus that number. And that gives me negative 3.54-ish. And then I have to divide that by 4.